All right, Unit 4 Pre-Cal Test Review. Remember, this is worth 5 bonus points. Okay, so all this here is just kind of reminding you about what we did this unit. You do need to remember that the amplitude is always positive. So always remember this is always going to be a positive number. Okay, so let's just start kind of going through these. Okay, so on the first one, this 3 right here, that's my amplitude. And again, it always is positive. The negative here is just telling me that's going to be a reflection. And then remember to find the period. That's where you do the 2 pi divided by b. Well, my b value here is that 1/3. So I'm going to end up doing 2 pi over 1 times 3 over 1, because I'd be dividing by the b, but remember we don't divide by fractions, we multiply by the reciprocal, which means that my period is 6 pi. Okay, on the next one we're talking about domain and range. So if we come look down here at 6, well, the domain is going to always be all real numbers. Okay, but then my range is going to be dependent on my amplitude. So the way that I had shown y'all that you can do it is d plus or minus the a. Well, my d here is 0 because it's not moving up or down. So this would be 0 plus or minus 6. So that means it just goes from -6 to 6. And again, if you're not adding anything at the back, it's really just going to be, plus or minus that first number. Okay, on the next one here, it's all about amplitude. So, for instance, if I take this last one, remember your amplitude is the halfway distance. So this is really from -4 all the way up to 4. Well, the total distance of -4 to 4 is 8. So really then, if I split that in half, that's going to be 4. So the amplitude is 4. All right, on the next ones, I'm just matching the graph. Okay, so on this one, I can tell that it's starting at 0, 0, and sine is what starts at 0, 0. So that's going to be sine x. On this one here, this is actually going to be cosine. And I'm noticing on this one there probably should be like a 4 right in front of there because of the amplitude. So this one will be y equals, it is a negative because it's opening downward. And actually, I'm going to write the amplitude in there. So -4 cosine x. And then this one here is going to be tan. It's the inverse of tan. So that one. Now, in class, we had also talked about this. Remember that this one right here, the inverse of sine, is going to start at 0, 0. And then the inverse of cosine will start at 0, 1. Okay, on these here, you've got your amplitude. So for the graph shown below, write the cosine equation. So what I'm noticing on this one is that the amplitude changed. So my amplitude is actually going to be 2. And again, I can tell that because this is between 2 and -2, which is 4, and half of 4 is 2. There will be no vertical shift. It does start at 0. Oh, I'm sorry, horizontal shift, doesn't start at 0. And also, it wasn't moved up. It's just literally -2 to 2, so there's no vertical shift. So my equation would be y equals, it's opening upward, my amplitude is 2, and then cosine x. All right, on this one here, my amplitude is going from -5 all the way up to 5. So that's 10, so half of 10 is 5. There's also no vertical shift, and there's also no horizontal shift. Okay, on this one here for the equation, it is sine, starting at 0, 0 there. Oh, I'm sorry, for the period for these two, it's just 2 pi. 2 pi. Okay, and then for the equation, it's going to be y equals. It is going up, so it's going to be positive. And then we said that the amplitude was 5, so 5 sine x. Okay, on the graphing ones, these are just your basic parent functions. So really the main thing here is knowing what it counts by. I'm not going to graph these, but when there aren't any transformations, you're really just sticking to these same numbers. Now remember the pattern for sine is 0, 1, 0, negative 1, 0. And then for cosine, that's where, again, if there aren't any transformations, there's nothing with the A or B value, nothing going on, you just stick with that really basic one. And then the pattern for cosine is that 1, 0, negative 1, 0, 1. Okay, on the next ones, we're going to graph and state the domain, range, and interval notation. So this is just graphing. I'm probably not going to do every single one of them. I'll just do maybe a couple. Okay, so on this one here, on the cosine one, I do notice that there's an amplitude of 4, and I'm also going to be moving it up 4. So this one's actually, hopefully it fits on here. All right, so let's see what we have. So I'm going to have 0, and then, or theta and y, okay. Now, I'm noticing it's cosine, okay. There's no b value or anything, so the period won't change. So 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And then when I come over here, again, I got to make sure I remember what pattern I'm going to use. So 4 times 1 plus 4, 4 times 0 plus 4, 4 times negative 1 plus 4, 4 times 0 plus 4, and 4 times 1 plus 4. Okay, so I can already tell that my highest number is 8. So when I'm talking about the range, that'll be there. And I just need to figure out what goes in the front. So that's 4, that's 0, that's 4, and that's 8. So the lowest number is 0. And again, I can still use that D plus or minus A. So that would give me 4 plus or minus 4. And you can again see the 0 and the 8. Okay, so when I'm doing this one, I am going to have some problems with graphing, so I think what I'm going to do is, let's see, 1, 2, 4, 6. I'm going to make it go off the graph a little bit. Well, if I do that, 2, 4, 6, 8. It's going to look a little squishy. All right, and then here, I'll skip every 3, so that's pi over 2, pi, 3 pi over 2, and 2 pi. I'm just going to fill out my domain right now since I know what it's going to be. And then I'm just going to go through and graph each one. So for 0 pi, which is right here, that's going to be 8. Okay, and then I have 4 here. And then I have 0. And then over here, I'm going to have 4 again. And then the 8. So it should look something like this. Okay? Alright, so this one here is pretty much the same thing, except instead of multiplying everything by 4, you're just going to multiply everything by 1/3. Okay, let me do the secant one. Okay, so on the secant one here, first of all, you have to know that secant is related to cosine, and that's going to be important because when you're doing your pattern, you have to know what numbers to use. So I know I'm going to be using 1, 0, negative 1, 0, 1. And I also know that I'm going to be multiplying those by negative 2. So it'll be negative 2 times that. So that gives me negative 2. That gives me 0, 2, 0, negative 2. And then over here, there aren't any shifts or anything, so 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Alright, so I'm going to make this, I'll make that 1, make that 2, and I'm going to make that negative 1, and negative 2. Okay, so now what I'm going to do is I'm just going to graph it. Well, actually, let me finish my counting. All right, so that's pi over 2, pi, 3 pi over 2, 2 pi. All right, so 0 pi negative 2, there's that. And then I'm going to have pi over 2, 0. I'm going to have pi 2, that's the maximum. And then really, I don't know if y'all have noticed, but they're always kind of symmetrical. Okay, so here's where I'm at now. Okay, now I'm not finished though, because all I've really done so far is I have graphed the cosine. I have not graphed the secant. Okay, so remember, the whole idea about secant is that it's 1 over cosine. So remember, this is really 1 over cosine. So what I now have to do is like, oh, I got to divide that by 1. Oh, I got to divide that by 1. Or do 1 divided by 0 is what I should say. All right, so that's actually going to be where my asymptotes are. So I'm going to put an asymptote at pi over 2. And I'm also going to put an asymptote at 3 pi over 2. And then this is where I create my curves. So I'm going to have a curve, another graph here. I'm going to have one here. And I'm going to have one here. Okay, so don't worry about domain and range so much on these. It's a lot different than the other ones, so don't worry about that. Hold on, my mouse just fell. Okay, now I'm going to look at, let's see. Woo! All right, here we go.